Hello, I'm here with Siddharth Sharma and Shamik Mehta. Thank you for attending this session with IIoT World. We're delighted to have you from Hitachi Vantara, and we'd like to find out a little bit more about yourselves. Would you maybe give us a start? And Sid, can I call you Sid?
Yeah, absolutely.
Yes. Just tell us a little about yourself, Sid, please.
Sid, I lead the entire business of IoT globally, and the business is pretty important for the group because our group is very asset-centric group, and IIoT, as we call it, is absolutely critical for an asset life cycle. Apart from that, the group also is very interested in products and smart assets. IIoT practice does that too. And pretty new to the Hitachi empire, if I may say. It's a massive treasure trove of knowledge and experience. And OT and IT is right at the center of the value prop which we take to the customers. And IoT Group is the channel for that.
As I mentioned, is Shamik Mehta. Tell us a little about yourself, Shamik. What's your journey and what brought you to Hitachi Vantara?
Yeah, absolutely. Yeah, I am Shamik. I'm the Director of Industry Solutions Marketing at Hitachi Vantara. I'm normally based out of Santa Clara. We are in the beautiful Santa Clara office right now and working from home, unfortunately, like the rest of us, but very much enjoying the California life. I've been here for 30 years. I got my master's degree at San Jose State University. And I started my career in semiconductors in the early 90s, starting in chip design and then moving into product marketing and strategic marketing, product management. And then about 16, 17 years of trying to figure out how to sell a better processor to a networking company or to figure out how to make a faster touch sensing, capacitive sensing chip to a smartphone that's going to go to one or more executive. I thought I had enough of that, wanted to have a bigger impact in the world. So I joined the renewable energy space. And in about 2010 to the end of 2016, I worked for a company in the renewable energy space, which was a very large independent power producer, the world's largest independent power producer, an aggregator of solar, wind, and energy storage technologies, called Sun Edison. Unfortunately, with the oil price crash in 2015 and a few missteps financially by the company, they went under, but it was a great job to work for. And that brought me to Hitachi Vantara. Because Hitachi Vantara at that time, with the Lumada having been announced in the May of 2016 timeframe, when I joined in January of 2017, Lumada was getting more and more popular in the energy and the confluence of energy with electrified transportation spaces. So I was a natural fit for me to come and start marketing IoT platform technologies and solutions in that space. Because in a renewable energy industry, we were a very early adopter of machine to machine. We had tags attached to inverters, solar inverters in remote locations, and we were catching live data, including anemometer data and including weather-facing camera data, and putting it on in a renewables operations center. So for me, it was a natural fit, and I've been here for 5 years now.
Absolutely. Well, that's very interesting. So here's a question for you, Sid. So now that you've been at Hitachi Vantara for 13 months, what do you think it is that keeps Hitachi Vantara's customers coming back? What does Hitachi Vantara have that's resonating with its customers, do you think?
I'm glad you started with that question because there's something very unique which keeps our customers coming back to us. See, like any other market space, we can look at IoT as a space which is IT, enterprise OT, but actually if you lift the hood, it's a very new market space. The real transaction, the buy, sell, transform transactions have just started to happen. I mean, in the last 4 or 5 years, you will hear some mega programs being conceptualized. Now, most of the customers are in a very critical stage of their transformation. They have either decided that how exactly IIoT can become a lever in their new revenue models or an amazing disruptor for their cost, because IoT can either take you into a new revenue zone or take out massive disruptive chunks of cost, which you always used to incur, or both.
Yes.
Now, the customers actually want to talk and work with companies which understand their industries intimately. And intimate understanding of industry is something which everyone professes, but it's very difficult to find. Now, if you're talking to a power grid transmission company, and we are talking about modeling their entire substation, their air insulated switchgear, their gas insulated switchgear, what exactly is the depreciation cycles of their existing installed asset base? Is it even worthwhile to digitally twin them? What kind of conditions you want to capture from them? A customer would not like to waste their precious time, money and energy with people who are not able to figure that out on their own. They need assets, they need accelerators. If you go to a shipping industry, logistics industry, they all come with very unique challenges, rail industry. So the beauty of Hitachi is that we operate in some of these industries. A, we do not need to explain that we understand them. B, if that discussion emerges that you have to explain yourself, then we have some amazing set of researchers who are creating next movements of these industries, who are creating the next generations of these industries. We spend close to $9 billion only on researching in these industries. We have close to 850 patents in rail, power grids, and transportation automotive systems filed in the last 5 years. I'm not talking about the lifespan of Hitachi. So it becomes very easy for customers to come back to us again and again because they like those conversations where IT, OT, intelligent products can come together and a program can quickly be launched rather than people trying to do a lot of drawing board and a lot of thinking exercises, which are basically disguised to learn about the industry by the providers.
So you mentioned digital twins there, and I'm curious, is that the kind of thing, like it's gone from being like a science fiction topic a few years ago to being really a very important component in the industrial Internet of Things these days? Is this the kind of thing that the customers are asking for these days, or is it still very leading edge? What's the situation there?
Yep. Again, a great question. See, actually, if a customer asks for a digital twin, I get worried because they are talking about the Steven Spielberg, James Cameron kind of a digital twin, where there is something which is digital twin should be an eventuality and enabler. It's basically the replication of thermodynamic, electromechanical, electrochemical conditions of a living, breathing, existing installed asset in a digital environment. And it just makes it very easy for someone to look at that asset remotely. So if you can twin an asset in a digital realm where all the real-time conditions of that asset can be monitored from a very far off place without you putting boots on the ground, and you can actually have a closed loop where you can make some changes and turn some knobs in the digital realm, which actually impact the physical realm. That is the digital twin which Hitachi works on. So a power grid to be controlled, a power grid in Finland can be controlled in a station sitting in Zurich. A rail system which is running in Scotland can be monitored from a control room in Dublin, Ireland. Now, these are the kind of digital twins which are not asked by the customers, knowledgeable customers. They know that it's a table stake. When a customer asks for a digital twin, it's usually that Hollywood model.
Avatar. They want an avatar, a blue one.
Exactly.
Yeah.
So that's
No, that's great. That makes a lot of sense. And the return on investment on those examples that you gave are really pretty obvious and really, really terrific as an area. So that's interesting. So I'm curious. So in the cases where you've got a knowledgeable customer and they are engaging with you, what's the usual method? Is there an extended period of understanding the business issue that the person's having, or I'm curious as to how the customer interacts with Hitachi Vantara. What happens when a customer comes to you typically?
Yeah. There are many archetypes of the customers. Some people are discoverers, and every customer is knowledgeable. Please don't get me wrong. I mean, even a customer who is coming for a Hollywood version of the digital twin is a knowledgeable customer. They want it for something else. And it's usually not industrial. Industrial customers are much more rugged and they look at digital twins differently. But uh, if an archetype of a customer is a discoverer, then we need to do a lot of discovery sessions to actually peel the layers of the onion, because they might come with a problem statement, but there is a root cause or a very germane problem hidden in the layers of the onion. There you need a lot of discovery sessions. We have to bring in our design thinking experts. We need to do a lot of workshops. Usually, some of those workshops are led by millennials who actually do not understand IIoT, but they understand the mind maps of customers and they can peel the layers of the onions. Then there are some customers who are in the other end of the spectrum. They want to scale out. They have done the discovery, they have got the concept, they have implemented a pilot, but now they want to go into 140 plants. They want to run into 40 countries. There, the problem is very different. There, you have to bring in the scale of Hitachi. Understand, since you are coming in, someone else has done the concept. So you have to understand what were the constraints of that concept. Every concept has constraints. Some are good, some are bad constraints. You have to minimize the limiting constraints and you have to maximize the delimiting constraints, and then roll this, scale this whole concept out. And in between these two ends of the spectrum, there is a whole host of archetypes. There are people who want to build a concept. There are people who want to implement it in small bursts of 5 plants, 50 plants, 500 plants. There are people who want to launch IIoT in their contract manufacturing. And that contract manufacturing is a very important part of the entire value chain. And all the contract manufacturers are not part of the business agenda. So you have to do a change management exercise at times.
Right. So that reminds me, if you don't mind me interrupting for a second, I'm just curious about that. One of the things that I know about IIoT in general is that it takes a life cycle to really understand. It might take a year before you can start to estimate what the return on value, the value is, because you have to go through all the seasons or you have to go through all the different portions of the cycle. So the return on investment takes time to be able to see it. It doesn't show up immediately necessarily. What do you think about that? Is there, in typical engagements, do you find that customers are doing a pilot version, or are they being patient and saying, we're going to give it more than 12 months before we start trying to, do our analytics to see what the return on investment is? Or what do you think the right model is for people to look at that value equation?
See, I think this question lies at the center of any IIoT practice strategy. And that is, in a way, one of my charters. I have to draft the strategy of our IoT practice. Now, I can again go into spectrums. One end of the spectrum is the entire future of a country. We are doing a project with City of London, where we have partners like Uber, Centrica. We have partners like
the UK Power Networks.
This project is actually called Optimize Prime. Sounds familiar, but it is Optimize rather than Optimize. And Royal Mail. now Royal Mail, Uber, and Centrica, they all operate fleets of vehicles. Uber, of course, but Royal Mail also, and Centrica has these vehicles which goes from house to house or install base to install base, checking, metering, picking data, etc., repairing. Now, this entire program is a test bed to analyze the impact of internal combustion engines moving to EV. What people do not realize is the cost of decarbonization. There is a massive cost of zero carbon or carbon neutrality.
Yes.
When these vehicles become EV, they will charge. The charging behavior is going to determine the load on the transmission and distribution, eventually on the distribution network. But if they're charging in bulk, then people need to understand how do they generate that quantity of electricity? When and how you should encourage these people, these fleets to charge. So what we are doing is we have created an experimental test bed, which is allowing vehicles to be converted into EV in short bursts. And then we are creating different scenarios of testing. Sometimes people are being asked to go to their homes and charge these vehicles.
Oh, interesting.
Sometimes they are being asked to charge in a depot. Sometimes they are being asked to charge in daytime, evening, nighttime.
Get a wide range of different data types. Yeah.
Exactly. And we are collecting these behavioral patterns and plotting them on the load on the grid. And basically, the final outcome of this project would be, it will be consumed by UKPN, and they are going to make a recommendation on how much of generation capacity has to be added in England versus how much of storage capacity and capacitance has to be added. The most rational scenario is that everyone should charge at night and it should all be in bulk. But there is not enough mineral base on this planet to service the entire movement of internal combustion to EV, right. Cobalt, nickel. That amount of cobalt and nickel is not present on the planet. So how do you regulate? One of the streams of this program will be the reharvesting of the batteries. Similarly, we are in a conversation with a very large automaker, global automaker, who are talking about the entire first life and second life of the battery. Now, the battery inside the car, when it is having zero remaining useful life for the car, is actually having 90 to 80% useful life for a battery farm, which can store electricity and power a city. So there is a first life, and then there is a second life, and then there is a third life. The third life is the reharvesting of minerals out of the battery. So they want to create a global command center which watches and this whole supply chain. Now, what is the ROI of these programs? These programs are massive programs. The ROI is national security, if you want to say. I mean, national security is hyphenated with energy security.
Energy independence. Yeah.
Then we are on programs where there is a massively important ultra high grade stainless steel maker in Northern Europe. They make, I'm very familiar with this organization because of my past life, but they actually make artisan stainless steel. Now that stainless steel goes into that luster which you get in the steering wheel of Maserati, or that steel is the signature of Nike in some of their buildings. So they make that kind of steel. Now the cost of making that steel and the cost of return of that steel is very prohibitive. We are actually implementing a program. We have implemented the phase 1. We are going into phase 2, where we detect the quality defect in the final cold roll at the hot rolling level to determine what kind of faults can emerge in this continuous process.
Great.
And that program is going to reduce the rate of returns. Phase 1 will reduce the rate of returns by around 20-25%. Phase 2 can reduce it by 40-45%. It's a rollout into plants.
I would combine the last two things that you said, Sid, and reiterate that customers keep coming back to us precisely because we have this knowledge about the domain that the customer themselves are in.
Yes.
We ourselves are a major manufacturer, we're the 24th largest manufacturer in the world. That we have over 30,000 plus employees just working in manufacturing.
Wow.
Inside Hitachi alone.
Yeah.
So we are a large manufacturer. So we've been understanding how to instrument our own assets for decades.
Mhm.
So we've understood what the machines are telling us by instrumenting them ourselves. We have been able to create the models that help us understand the behavior of the assets in current times, as well as predict what they might do in the future. Then we have the R&D and the IT sciences, our ability to create the AI and the ML modeling behind all of this. And finally, thanks to people like Sid and his practice, we are able to provide the guidance needed by our customers, since they cannot implement all of this themselves. We are here to help them go through this, because this is not a simple job of downloading software from a website, paying with a credit card, unzipping it on your desktop, and installing it, and you're ready to go. That's not how this works.
Certainly
It requires decades of experience. It requires deep understanding of the customer's business model and then bringing it all together. And I think that's a big reason why I've seen customers come back to us. And that's probably what you see too, right, Sid?
Yeah, I can't agree more with.
Absolutely. Well, that's quite fascinating. I'm very curious about what some of the big trends that you're seeing these days. Certainly, I can imagine that what you just described about the situation in the UK with electric, EVs and electrification projects, and that's obviously one of them. What else is it that we're seeing out there these days in terms of I know there's a lot of automation going on, and how about analytics? What's new in the field that you're seeing that's kind of emerging these days?
In a field like IoT, where the power of IT is in data, computing and processing power, the whole multi-tenancy of cloud gets merged with the power of OT, which is all about time series, proximity to the physical world. OT is all about proximity to the behavior of the physical world, equipments and assets. When these two worlds collide, usually a big IIoT program is formed. Now, the big mega trend, which I personally believe is going to happen, is further confluence. There will be a further blending of these worlds.
Mm-hmm.
And what will emerge out of this blending is something what happened in the ERP world. In ERP world, what happened was that first, a financial system was the need. Then it became an enterprise system. Then the ERP systems knew that they cannot just be transaction processing. They went into OLAP and then UI, and everything then became for a customer. Now, in IoT world, for a customer will eventually become an industry cloud. The one big idea which Hitachi currently is taking and working day and night is to create industry clouds. We believe that Hitachi is perhaps the only organization in the world which can create some of these industry clouds. Industry cloud for power transmission, industry cloud for power sector, industry cloud for aftermarket, industry cloud for railways. Because an industry cloud starts at the top from the personas, the people who interact with these solutions, which we eclectically called analytics, data science, ERP, CRM, e-commerce, IoT. No, they all come together to provide a value to a persona.
Yes.
So there is a persona at the top. Then there is a business rule below that persona. Then below that business rule are the set of systems. These systems can be completely on cloud or hybrid, on-prem, or in transition. Below them is the entire power of the data of that industry. The data of the industry is very different. You can take the data of the industry, and through time series and the nature and knowledge embedded in the data, an expert with tribal knowledge can tell you that this data belongs to my industry and this data doesn't. And below that data is the vast computing power of CPUs and the machines which are running in this world, which is fast becoming a semi-data center in itself. Below that, there is the networking layer, and it is all under the umbrella of industry-specific security, because every industry has a different security demand and a security threat. A rail infrastructure and power infrastructure, you can see what is happening in Ukraine, is actually, they are not being attacked by physical bombs because they were already gutted by cyber bombs. So the security need of a critical infrastructure is very unique. A critical infrastructure in an automotive assembly line has to be secured. It's very important. But then there is a critical infrastructure in a chemical plant. Then there is a critical infrastructure in a power grid. So there are different levels of critical infrastructure. And hence we believe that there are certain industries in which Hitachi can lead and be ahead of the curve with a concept, a solution called industry cloud.
And if I may add to that challenges question or the trends that we are seeing, I would say that our customers, much like many of our peers and ourselves, find it hard to find the talent. It's difficult to find people who are willing to join industries such as the power generation industry or cement manufacturing, essential industries that everybody needs to survive. But it's getting very, very difficult. And I don't think we are building talent fast enough anywhere in the world, not just in the United States. I think every country has this problem where we need people with hard skills that can take some of these next level concepts like creating, learning and building a machine learning model and then creating something of value out of it, or creating processes to get insights out of massive troves of data at the data side. So that's become a problem. That's one thing that I think we all struggle with, and our customers increasingly come to us because of that domain knowledge that we can help them provide. And the second thing I would say is, as customers and all businesses migrate their workloads to the cloud so that their programs and applications work anywhere in the world seamlessly, across any device or any operating system or across any cloud environment or not. I think that there's tremendous amounts of complexity in being able to, lift and shift or migrate your applications or design them natively to build and run in the cloud. And that is what Hitachi Vantara is so good at. So we have this entire business that runs on helping customers migrate workloads to the cloud or install it in private data centers to keep it secure. Maybe it's regulation bound and it has to be kept on premises, whatever combination that happens to be, on-prem, hybrid, or in the cloud, moving applications and their critical programs correctly while keeping in mind all safety and regulation considerations is something that we excel in.
Indeed. That's terrific. I guess my last question for you, either of you, is maybe you could tell our audience a little about any notable gotchas from your experiences that have guided your current approach and how you are likely to approach future problem solving.
I have an example ready to go if you want me to.
Yeah, please.
What we find is in the world of industrial IoT and what affects, simple things like maintenance, even a simple act of trying to instrument a certain kind of asset that you have, even if it's very small in a giant scope of things, it has ramifications throughout the company and it changes the culture massively. So for some years ago, we were working with a local transit operator, and they had some train cars that they wanted to install sensors in because they wanted to check when the doors are closing properly or not, if there's a delay or not. And instrumenting that with IoT to figure out whether there's a variation in the current that goes to the motors from an IoT technical perspective is not a difficult thing to do. It's not even expensive. The sensors are $1.50 each. And it is, 8 motors in a car, in a typical rail car. So that's $16. It's not a big deal there. But the change that it impacts to the process of how a rail car is maintained, even for just the doors, means you have to digitize the records. You have to affect union workers. It affects their IT systems. It affects their MES and CMMS systems. It affects how the data gets translated and crosses over into the IT organization. And it affects so many changes, all the way from finance to human resources to labor negotiations to the actual maintenance and the technical work required. We've now understood that both departments, the OT and the IT department, have to be able to get involved at the right time, right from the start. And it's not just one department that you talk to. That's why the IT-OT convergence is so important. And that's why we've been focused so heavily on it and doing well in that area.
A terrific example, and it really ties together what Sid was saying earlier about the confluence of those two worlds. That's great. Well, it's certainly been a pleasure chatting with you, gentlemen. Any closing thoughts you might wish to share, or let's have them now.
First of all, thanks for asking such pertinent questions, because we are also learning in this world. And when we go to a customer, there are a lot of new things we find every day. But it's just like a book, a new book. If you understand the country, the context of the story, it becomes very easy to follow the story. Otherwise, sometimes if you do not understand the context, it becomes very difficult to follow the story. In IoT, the domain understanding, the business understanding helps us in understanding problems sometimes very quickly and sometimes much more easily than others. But overall, a customer should not be in a hurry to launch an IoT project. Sometimes we have seen that they are in a hurry. A business outcome of IoT can be truly transformative, but it's usually discovered through a lot of discussions with business, OT and IT, which Shamik was also talking about. And implications of an IoT program are also much beyond the realm of what looks very bright and shiny on a paper. It can be very devastating for certain ends of the business, or it can be absolutely transformative for one business which is not even invested in the first phase. So a lot of thought, a lot of sponsorship, and cautious first few steps. I think then IoT can truly realize its potential in industrials.
Yeah, well said.
Yeah, that's interesting. It's almost, in a way, it's IIoT ceases to be thought of as a technology, and it becomes more of an enabler of a change in the way of thinking. So
Actually, yes.
Yes. Well, certainly a pleasure speaking with you both. IIoT World is here with Siddharth Sharma and Shamik Mehta. Thank you both, gentlemen, and good luck with everything and all your great works at Hitachi Vantara. Thanks again.